In today's lesson, we will do marking for Worksheet 7.2. Please make the amendments as shown. Question 1a. An iron rod is placed into a cup or a basin of ice and water for 10 minutes. State one possible observation. The iron rod becomes shorter in length, or it contracts when placed in cold water. Using the model of particulate nature of matter, explain your answer. When you see this, the model of particulate nature of matter, please use the word particles in your answer. So, in this question, you are supposed to explain contraction. So you want to talk about the particles in the iron rod becoming closer to one another. When the iron rod is cool, the particles lose energy and they vibrate less vigorously. So the particles move closer to one another, causing the volume of the iron rod to decrease. One thing to take note is the size of the particles should not change. Question B. The iron rod is then heated very strongly until it melts. Describe the movement of particles in the iron rod. In this question, the iron rod is heated and it expands. But it is not only heated until it expands, it is heated very strongly until it melts. So you are to describe the movement of particles in this iron rod. This animation shows the particles in the iron rod vibrating, and as temperature increases, the particles vibrate even more vigorously. As you can see, they're vibrating faster and faster until it reaches the melting point and the particles start to slide over one another. This is a very common question during examinations. You explain it this way. The iron particles gain enough energy to overcome the very strong attractive forces in the solid state, and the particles move freely and randomly and slide past one another when it becomes a liquid. Another thing to note is during melting, the temperature, which is the melting point, remains constant because the heat energy absorbed is used to overcome the very strong attractive forces, so the particles can move freely and start to slide past one another. I want you to observe this graph. Here the particles are already in the melting and the temperature remains constant. This part is the melting point. From the start of melting to the end of melting. Here, the particles gain enough energy and they overcome the attractive forces. Question 2. A long steel bar is fixed by a nut at one end and an iron pin at the other. It is heated very strongly for 5 minutes. Let's see what happens. This is the steel bar. Yes, it expands. So the process that took place when the steel bar was heated is expansion. Question B. We are to use the model of the particulate nature of matter to explain expansion. This shows the particles in the steel rod before heating. And this shows the particles of the steel rod after heating. What has changed after being heated? It is the space between the particles, right? So when the steel rod is heated, the particles gain energy and they vibrate more vigorously. So you can't see it here, but the particles would vibrate more vigorously or faster, and they start to move slightly apart from one another. And thus, the size after heating would be bigger. Okay? To put it in words, when the steel bar was heated, the particles gain energy and vibrate more vigorously. Thus, the particles move slightly further apart from one another, causing the volume to increase. Question C. Suggest why the iron pin broke. Let's look at the diagram again. This is the iron pin. And what happened that caused it to break? Let's look at the question stem from here to here. The nut was tightened at regular intervals during heating. So this steel bar had expanded and the nut was tightened regularly. Then cold water was poured onto the heated steel bar. And the iron pin just broke into two pieces. Why? Because the steel bar contracts. And this force of contraction caused by contraction will cause the iron pin to break. Question 3. An iron ball was placed in an iron box. And first, this iron ball was taken out and heated very strongly. And after heating, this iron ball couldn't fit back into the iron box. This shows a metal ball and a ring before heating. And the ball can fit right through the ring. Now the metal ball is being heated strongly. On heating, the metal ball expands. And now it can no longer fit into the metal ring. Right? It gets stuck. So when the iron ball was heated, the particles gained energy and vibrated more vigorously. So the particles move slightly further apart from one another, causing the volume of the iron ball to increase. So as you can see, this is really a standard model answer for expansion. So this is something you need to learn. Question 2. The size of the particles of the iron ball remained the same when the iron ball was heated. Take note, this is not referring to the size of the entire iron ball, but rather the size of the particles inside the iron ball. So it should be the same. So during expansion, only the volume of the iron ball increases, but not the size of the particles inside it. B. Think, how can we make the iron ball fit back into the iron box? Explain your answer. Yes, one of the ways is to heat the iron box and it expands. So the iron ball can fit it back into it, or you could cool down the iron ball in ice water, causing it to contract. And when its volume decreases, it would fit back into the iron box. Our last question today is based on a graph. And how do we interpret this graph? This x-axis is the temperature. So we are concerned with temperature at 4 degrees Celsius. And the y-axis is the volume of water. Right, question A, what happens to water when it is cooled below 4 degrees Celsius? So we are looking at 4 degrees Celsius and being cooled in this direction. So what happens to water? You see a rising trend when it's cooled to zero. So the volume increases or water expands. Question B. Explain what happens to the density of water when it boils. Boiling occurs at 100 degrees Celsius. Okay, let's look at the graph. What we're concerned with is this section between 4 to 100. So you see what happens to the volume of water when water is being boiled. The volume increases. Okay, and how does volume affect density? I've written the formula for density at the top. So you see, as the volume increases, when mass is divided by a larger volume, density will drop. So the density of water decreases. And question C, state the temperature at which water has the highest density. It would have the highest density when the volume is the smallest, right at 4 degrees Celsius. During winter, when the temperatures are cool to 4 degrees Celsius, the water will decrease in volume, so making the density greater. So the colder water will actually sink to the bottom. However, when the temperatures drop down to zero, you can see that the water will expand and making the density decrease. That's why ice at 0 degrees Celsius will float on water. This allows the fishes and the plants to survive even in icy conditions because ice is formed at the top layer. We have come to the end of the lesson. Make sure you have done your corrections. If there is anything you do not understand, please clarify with your teacher during the Google Meet sessions. Thank you.